So for this build, you only need three things. So you need a long spoon. It can be a wooden spoon from the kitchen like this. It can be like a scoop. It can be a plastic spoon. Whatever it is, as long as it's long like this and it has some kind of scoop on the end where you can put the things you're going to launch. So this is going to be the bar in our lever as we build this catapult. And I'm sure you guys remember right at the beginning of this whole social distancing COVID-19 thing, it was impossible to find toilet paper anywhere. Well, hopefully you guys were able to stock up now, because you're gonna need a toilet paper roll for this. This is gonna act as the fulcrum of our lever. And then the very last thing that we need just to tie it all together, literally, is some rubber bands. So this is a really simple build. You're just gonna take some rubber bands, 2 is a good amount, and you're gonna wrap these around the toilet paper tube like this. You only really need 2 to start with. You don't wanna put too many on because then you're gonna squish the whole roll and then it'll fall apart. But what you really wanna do is make sure that they cross over and form an X shape like that. Then you can take your spoon and we're gonna take the handle of the spoon and tuck it underneath that X shape so that it's attached like this. It's gonna look something like that. And that's really the end of the build. Now what's great about this is that we can play with the variables a lot. So this is our fulcrum. This is the part that doesn't move. And in our lever, this is going to be the input and this is going to be the output. Now this is a catapult. So we want to set this up so that we're getting lots and lots of speed on the other end because we're going to be launching bits of popcorn. So let's get some ammo out on the table. Now, if you do it right in the middle like this, you're going to get no advantage. There's not going to be any extra speed right here. And there's some other limitations that we'll see right now when we test. So when you test, you can just hold down the tube in the middle. So remember, the fulcrum doesn't move. And then you're just gonna apply some force here. Push this down to the table as fast as you can. Just be careful. This is delicate. You don't wanna squish your very important fulcrum here. So let's try it out. All right, so that's not very far, right? But let's adjust this. Let's try going this direction. See what that does. So we've got a very long bar here. We're getting lots of advantage on this side. Let's see how that does. Let's try it again. It's not really helping. It's because the way that this is set up, with the longer bar on the input side, we're going to be stronger on this side, but we're also going to be slower. And for a catapult, we want the opposite. So let's go to the other end. Let's try it this way. So now our input's shorter, our output's longer. It's going to get us extra speed. Let's test that out again. All right, so now we're getting somewhere. So what we can do to test this is we can get a ruler or a tape measure, lay it down on the table like this, and peg it right there by the fulcrum. And then we can test this out. That way we can see just how far it goes as we do this. Let's try this. Well, definitely have to work on our aim here. Try it again. All right, so that's looking like it went about 11 inches. Now we can change this up some more, make it a little bit more extreme. But there are some limitations here because you still need to be able to push on that end. Still about 10 inches. That might be down to form. Let's try it again. And there we go, best result. It's 20 inches. So what you guys can do is you can build this at home and then maybe you can jump on a Zoom call and share it with your teachers. If you do measure it, you can keep track of that. We can see who gets the best catapult with these very simple materials.